In this project, we're going to explore how to deploy Postgres databases on AWS using fully managed Platform as a Service offerings. Postgres is a powerful open-source relational database, and AWS makes it easier than ever to run it securely and at scale, without having to worry about maintaining the underlying infrastructure and servers yourself. We'll be deploying two different services. First, Amazon RDS for Postgres, which gives you standard Postgres experience with fully automated backups, patching, and scaling. It's a cost-effective option that's great for development environments and predictable workloads. Second, we'll look at Amazon Aurora Postgres Compatible. Aurora is designed for high-performance enterprise-grade workloads. It offers up to 5 times the throughput of standard Postgres, supports distributed storage across multiple availability zones, and allows you to create up to 15 low-latency read replicas. Aurora also includes advanced features like near instance point time and recovery and seamlessly compute and storage scaling. In this project, we're going to deploy the following resources: a custom VPC with subnets and routing configured for our databases, security groups that control network access to Postgres, 2 separate Postgres environments, a primary RDS Postgres SQL instance with a read replica, and an Aurora cluster with a reader and writer instance. We're going to use AWS Secrets Managers to securely store database credentials with randomly generated passwords. We'll set up everything using Terraform and shell scripts, so you can easily customize, redeploy, or tear it down whenever you need. To make it more practical, we'll also load the Pagula sample database, which is a well-known sample database out there, which is modeled after a DB rental store. This gives you realistic tables and data to experiment with SQL queries and joins, and learn how Postgres behaves in a real-world scenario. At the end of this project, you'll have a complete end-to-end example of Postgres infrastructure on AWS, all defined as code. You can easily adapt this project for your own projects and use it for development environments, staging systems, or even production workflows with a little work. Now let's take a look at the architecture diagram. So we're going to deploy in US East 2 like our other projects, and within that region, we are going to create a VPC and then 2 subnets in the VPC, subnet 1 to subnet 2. And we're going to end up placing an Aurora reader instance in one of the subnets, and then an Aurora writer instance in the other subnet. And then with Postgres, we're going to put the RDS primary instance in a subnet, and then we're going to have a read replica in the second subnet. When we provision everything, we're going to create credentials into our database, and we're going to store them in Aurora Credential Secret and the Postgres Credential Secrets. Okay, let's talk about the differences between the RDS Postgres variant and the Aurora Postgres variant. And we have in the documentation a bunch of comparisons to look at. And I guess to start with, you can really think of the Postgres for RDS as Amazon provisioning an EC2 with Postgres installed, and then they manage all the patching. So that's generally how it works for RDS, is you have a single instance there, and you can scale it vertically by changing the instance types. But it really is much like an EC2 instance deployed self-hosted, but Amazon manages it. So you get the platform as a service features with the managed EC2 instance that you don't see. And to compare that with Aurora. Aurora it has several different modes. I use serverless in this case, which to me suggests that it's probably containers on the back end. But it's much more scalable, and it can scale horizontally, and whereas the Postgres for RDS mostly scales vertically. And so we've got the key differences here. Let's talk about, really, there's 3 that I think are really important. The first one is performance. Aurora is designed to be much higher performance for real-world workloads. The PostgreSQL version works well for standard workloads. It's probably cheaper for standard workloads, but if you're building a real high availability application that needs high performance, you're going to want to use Aurora. So let's talk about replication. That's another important difference. With Aurora, you can have 15 low latency replicas. Those replicas are near synchronous. I think there is some, if it's cross region, it's not perfectly synchronous, but if it's in the same region, it's synchronous. So all your readers are going to be updated at the same time of the writer, and you have 15 of them. Whereas for the RDS, you have 5, and it's not totally synchronous. It's asynchronous. It's pretty close to synchronous, but it's more of an eventual consistency model rather than an ACID model, which the Aurora one handles very well with the readers. We talked about scaling and performance, and with Postgres for Aurora, you have serverless, and it also can scale compute and storage seamlessly. The only really scaling you have for the RDS instance is you can vertical scale. There's different instance types associated with it. You can make them bigger, you can give them more resources, but it's really focused on the vertical scaling, whereas Aurora is the horizontal. The final thing I cover as far as the differences is cost. Now, Aurora gives you a lot more, and so you can expect Aurora to cost you more, particularly when you start using more replicas and the advanced features. Now, I typically start with serverless, and serverless is a little bit cheaper to start off with, but when it gets to a load, then it's going to be more expensive. So I really like the fact that you can start your development environment with Aurora with serverless. You can specify kind of low thresholds. I think they call it Aurora capacity units, ACUs. You can start that relatively low and bump it up. But in general, once you get it to a full system, full load, it's going to be more expensive with Aurora compared to RDS. So RDS is sort of fixed, predictable. Aurora is dynamic, and your costs can get higher than RDS. So choosing, what service did you choose? If you need a cost-effective, fully compatible Postgres solution, then you should use RDS. There are some very advanced features that are only available in Postgres RDS, where Aurora has its own feature set, which is slightly different. It's a little less featureful than standard Postgres. Now, if your application needs high performance, scalability, and advanced features like global replication for DR, you definitely want to go with Aurora. Okay, now let's talk about the prerequisites you need to build this project. Now, first off, there's a project out there called AWS and Terraform Easy Setup, which takes a very simple AWS project and sets it up. But with this one, you're going to need an AWS account, and included with that AWS account, you need a secret and access key. You need to install the AWS CLI. Then you need to install the latest Terraform to run the build. And then you need to install the Postgres pSQL client. I could put the command for Ubuntu, but it's available on just about every distribution. And this will allow us to load the Pagula database. That's what we're using pSQL to do. And then finally, there's a GUI client called pgadmin4 that I'm going to demo. You might want to use it, download it to test. Okay, now we're going to build the code. So what I'm going to do is copy this line right here. I'm going to go into my Ubuntu development environment. I'm going to paste it in. This is going to clone the code from GitHub. And first thing I'm going to do, I'm going to run check env. And that's going to go and check all these commands. Do you have AWS? Do you have pSQL? Do you have Terraform? We also have JQ, which is for the JavaScript thing in the bash command line. But it's tested everything that's there. It's tested the AWS connection. It uses the environment variables to make sure it can connect. And now we're ready to run the build. Now the build here takes about 30 minutes to run. Okay, the build has completed, and so now what we're going to do is go into the AWS console and take a look at what exactly got built. So you want to bring up your AWS console, and there's really two sections that we're going to look at first. The first one is Aurora and RDS. So you can click on that. Make sure you're in US East 2, Ohio. And what you will see is we have 4 instances, but it's really around 2. The first instance is the Aurora Postgres cluster. It's a regional cluster, and we've defined one writer and one reader. If you go look at that, We public in this. I don't think you would ever do that in a production environment, but just to make it simplest for us to debug this, we've made these public. And so what you end up with is you end up with two endpoints that you can connect to in this deployment. The first one is the writer, the main endpoint, and the second one is the reader. Now, if you were to have multiple endpoints, it would be load balanced. So if I had multiple readers, you would have just this one read-only one, and it would be load balances between the amount of, you could have up to 15. So we've got that configured. We're in serverless mode. From here, you can go and do your backups, and it's all managed for you. And the configuration, we are Postgres 15.12. We've set the master user ID and password to be Postgres, and that's just the general configuration. Now, the thing to keep in mind with these readers and writers is readers are completely synchronous with the writers. So if I go write data, the next reader is going to get that data. So it's fully ACID compliant. So that makes it very, very good for reliability. But you can have up to 15 of these. Now, the other thing is there's this notion of failover. So I can go in and I can say, go in here and say, let's failover. And I'll run that. And all it's going to do is switch to reader and writer. Normally, failover happens for you automatically. And it's going to fail over. And you'll see that the reader and writer will get swapped. So I'll give that a minute to run. Okay, the failover happened, and it just swapped the reader and writer. Now, normally, that all happens for you, that the Aurora system will detect if there's a failure and automatically fail over to one of your readers and writers. I think the only scenario where you would manually fail over would be if you have a cross-region replica, then you have to manually do it. But for the most part, Aurora handles all this failover for you, and you don't need to worry about it. Now, the other thing is I did do it in serverless mode, and when you do that, you specify something called Aurora capacity units, and so this sort of gives you a range where it can flex. Now, you got to be careful with this, because what will happen is if you exceed your capacity units, it gets really, really slow. And so if you don't know that and you notice your databases or the connections are working, but they're getting flaky, it's sometimes a little bit hard to debug. So you just need to make sure if you're in serverless mode that you're on top of what your actual usage is with your capacity units, and so that it will perform properly. So that is it for the Aurora instance. So let's go back to databases and let's go to the Postgres RDS instance. So I click on that. And again, we made this public, which you would normally do. The configuration is you use, this is sort of like the EC2 instance types, because beneath the covers, Amazon's actually deploying an EC2 for you. So you've got the storage, it's EBS. So these are very EC2 type options. Again, you have the automated backup and maintenance, so you don't have to worry about that. And you've got this replica. Now, this replica is a little bit different in that it is asynchronous. It's more like eventual consistency, and you can have up to 5 of these. But again, they're asynchronous. So if you absolutely have to have the right data with like ACID compliance, then you need to be able to you need to use Aurora if you want readers and writers. The other thing that's interesting is, what does it mean to do failover? So I'm going to do something here. I'm going to go and I'm going to say promote. Now, what is promote going to do? Promote is actually going to, and I go ahead and run this. Promote is actually going to, I'm not going to automated backups, hit promote read replica. That's going to take this instance right here, the Postgres RDS replica, and promote it to being a full instance. Now, after you do promotion, you now have 2 completely independent RDS instances. So it works very differently with RDS with promotion, because when you do failover, you're all within the same cluster. It's going to reuse instances. Here you do promote. This instance is now going to be a sibling of the parent, and they're completely independent at that point. So we'll let that finish, and I'll show you should get 2 siblings at that point. Once the promotion completes, you'll notice that the replica is now up here with the RDS instance. So we have two fully qualified instances now. They're not connected anyway. They're not going to be replicated. And you can use that for various recovery scenarios. Again, the most robust recovery and high availability is always going to be Aurora, but there are, things like promotions or store from backups that you can use for DR scenarios. But in general, for large solutions, you're going to want to use Aurora for scalability and resiliency. Okay, so that's it for the RDS instances. So the next thing we'll do is let's go to Secrets Manager and let's look in Secrets Manager, and you're going to see that we've stored our credentials. We've generated random credentials for each one. So for the Aurora credentials, we can go in here. We can say retrieve secret value. It's going to give you the endpoint, the user ID and password. And then we can go and open link and tab. I'm going to do them both because this is the prelude for the demo. So that was the Aurora credentials, and now I'm going to do the Postgres credentials and do retrieve secret value. Okay, for the demo, what we're going to do is we're going to use this pgadmin utility, which is in the requirements section, and we're going to define servers using those secrets. So let's first define the Aurora one. Let's do a register server, and let's go and call it Aurora. And then connection, I'm going to go back here. I'm going to say Postgres. That's the endpoint. Then I'm going to go to password. We're using default Postgres user ID. We're going to say the password here. We're going to save it. And we're going to hit save. So that's the Aurora one. Now let's create another server, which is register server. And let's call RDS. Go to connection. Go to Postgres here. Click on that, put in the endpoint, and type the password, get the password, put the password in there, and save it for future. And then hit save. All right, so we've defined both databases in there. We're just going to interact with one to keep it simple, but you can see they're both there. So if I have Aurora, we've got the Pagula database, which has the, where's the schemas, public, tables. You can see you've got all the DVD related. It has the films, it has the inventory, it has the customer data, and they all have foreign keys. So if I click on actor and I say view data, I'm just say first 100 rows, it's got a bunch of cute actors that don't actually exist in here. And they're starring in movies that don't exist. So if I go and do view data, first 100 rows, get the films. And what you'll notice is you've got like the primary keys and the various things. So that's, it's a fully formed database. You can go Google Paglia and it'll tell you all about this database, but we just load it from the open source tools. We also have it in RDS. It's the same database. You've got database Paglia. And let's go to schemas. Same deal. You've got the tables, just whatever. And so we'll do one final thing before we clean up, and that is I'm going to go to my database and I'm going to say, I'm going to use the query tool, which just allows you to put in freeform SQL. And I've got a couple of SQL in the documentation that does, fairly trivial join. So I'm going to copy this, and it's going to join a couple of tables together that will give you what actors are in what movie. So we'll do the first one. Hit F5 to submit. And you can see you've got the movie and then the actors, and it's joining several tables to get that information. And then the other one that we have is very similar. Let's go to Query Tool and go back to the documentation and get the second query. Put that in, and you will get a slightly different view of the same information, where we have the movie and then a common separated list of all the actors in the movie. So that's pretty much it for the database. Like I said, you can there's plenty of documentation on this database if you'd like to do some more advanced things. But at this point, we're done. And what you want to do is you want to be a good steward of your cloud account, and you want to take down this account. So let's go back to our Ubuntu development environment, and let's run destroy. Now destroy takes about a little under 10 minutes.